Hi, my name is Richard Hoehn. I'm presenting AWS Polly and S3 for MTSU's CSCI 7400 Assignment 2. So the introduction to AWS Polly. Amazon Polly is a cloud-based service that converts text into lifelike speech. It supports neural text-to-speech or NTTS voices that deliver human-like speech and pronunciation. It's incredible. The common use cases are lots of video games, e-learning, and accessibility for visually impaired and other disabled people. And the big benefits of AWS policy is, of course, it's very cost effective. You only pay what you use. So, as an example, about 50 hours of speech synthesis will be about $22. Very low latency. In the demo, we'll see it's like in the 200 to 300 milliseconds. Quality is very good, solid pronunciation. And what's really interesting is AWS Polly supports many different voices. So you can choose from different dialects or different accents throughout the world. Supports French. And in the demo I'll be using, it'll be Voice ID Ruth, so a female voice. Why Polly? So text-to-speech in the cloud, the ability to have an API to convert text into speech scales incredibly well. It also allows for access to broader, more diverse audiences. So text to speech opens doors for people with disability, second language learners, and other adults struggling with increasingly complicated user interfaces. And we've seen that there's better outcomes in corporate learning programs. Everybody learns differently. Some people prefer to read content, some prefer to hear content. But studies show that bimodal presentations, in which materials are delivered by text and speech simultaneously, usually do the best. For example, this PowerPoint right now, me speaking to you while you can read the PowerPoint, is bimodal presentation. Continued, who's using these? News sites, of course, use them. USA Today, the Washington Post, CBS, to give readers the ability to hear their stories. Telephony, right? Customer service calls. Best Western, Twilio, Vonage, they all use AWS Polly for people to interact with them on the phone. And then lots of learning sites like Duolingo, Riby, Robots use that to teach STEM, games, songs, and other creative activities. Second, I'll introduce AWS S3. Most of us know that, so it'll be a short introduction. The key thing with S3 is its simple storage service, provides very, very high durability and accessibility for websites, mobile applications, and backup. It's really flexible, so it allows any type of object store, primarily used for data backups and archiving, and its cost is really low. So S3 is great in that you pay almost nothing to store the data, and you really, as a SaaS service, only pay when you extract data from them, which makes it really good for backups. Another introduction to just round off this presentation is introduction to Ready to Learn. So Ready to Learn is like a pre-K through third grade supplemental educational app. It's used by students in Canada and the US, and it really aims to improve the reading, writing, and math skills of these kids. It's a teaching platform, not a testing platform, so it helps kids learn. It'll be really released in August of 2023, and there's a website below. And I'm using Ready to Learn to kind of drive home how one should think about AWS Polly and how it can help. So a Ready to Learn or R2L use case for AWS Polly will be something like this, and that's why I was interested in it. Kids are learning on the app, and at some point they will get stuck. They just can't figure out what this simple math problem is. The kids that are using this app are, like I said, K through third grade, so they can't really read very well or not at all, and have a hard time kind of learning from just reading. So where text-to-speech comes in is that the Ready to Learn app can try and get kids unstuck with their own contextual problem, meaning the app knows what it asked the kids and knows what the kid responded with, and can build text to then convert into speech on the problem and possibly the solution. Since the round trip is like 200 milliseconds, the kid doesn't have to wait too long to get answers, and really can hopefully get unstuck. And this is where, some of the demo will come in later on, is, how you can interact, how you can enter text and then get speech back. So the demo that I would like to show for MTSU here is I wrote a small application, Node.js, that will ask for a user's name, and I'll type in MTSU CSCI department, and then it creates a text with the name that we just typed in, the day of the week, and how many days are left until the weekend. And that will really illustrate how the text can constantly change to get new voice out of it. So we're going to send that text via an API to AWS Polly for synthesis, which in turn will return a readable stream or a readable MP3 stream. We're going to save this MP3 file to disk and then upload it to S3 as a backup. I'll then retrieve its size that we uploaded, so I can kind of compare it to what I saved, just to make sure that I actually backed up my data correctly. And then as a fun exercise, I'll actually play the sound that we had just got from Polly. Okay, so I'm going to switch to my terminal. So this is the application, index.js. It's a very simple Node application. We have some setups here. I assigned AWS Polly speech synthesis client right here. I assign my S3 client right here. And then I go in and ask for the user's name. Hi, what's your name? Get the date and time. And then these are the Polly parameters that I send to AWS Polly. So I tell the engine that I want it neural. I want my output to be MP3, and then the text is hi, the username. I hope you're doing well on this beautiful day of the name. Today is Thursday, and how many days are left to the weekend. I package those up, and then I send it to AWS Polly for synthesis. I will get an audio stream back, and then essentially I'm going to pipe or save the stream to my local disk and upload it to S3 here, get the size back down from S3 to make sure I actually uploaded it, and then finally I'll play this sound. So I'm going to open the terminal below here. We're going to do npm run the demo here, and it's asking me for my name, so MTSU CSCI department, and I'm going to hit enter.
Hi MTSU CSCI department, I hope you are doing well on this beautiful Thursday. Only 2 days until the weekend.
So you see here, it did work. It sent it the round trip to AWS Polly. It was 310 milliseconds. I've seen it as low as 200 milliseconds. It took 200 milliseconds just to save to my local disk this MP3 file. It took 380 milliseconds to upload it to S3, and then 44 milliseconds to get the size, which is 43 kilobytes to download. And then playing the sound was 7.7 seconds kind of thing, so quite fast. And just to prove that this is not a canned demo, I can run it again. I can say Richard.
Hi Richard, I hope you are doing well on this beautiful Thursday. Only 2 days until the weekend.
You can see, because I only said Richard, it was 6 seconds instead. So in conclusion, what we saw here is Polly is really, really fast. And our demo was about 300 milliseconds, but in previous tests, I was down into 200, 250 milliseconds for 7 seconds of audio. I love that it's pay-as-you-go, so I envision this is a very good way for other developers to really get into speech synthesis and help build new and exciting applications and make it easier for people to interact with it. I felt it was really easy to use. So before this assignment, I myself, Richard, had no prior experience with AWS Polly, and it only took me a few days to get a good understanding of it and get it all tied into this little small application I showed you. And this, really leads me to really think about this seriously in terms of ready to learn, so that I'll use it in the future. I think that will be a very cool thing to start working with. Thank you for your time. All details, source code can be found on Git with the URL here below, and then also my references and citations are on the last page of the PowerPoint. Thanks for your time. Goodbye.